All right, hello everybody. So we covered the arithmetic sequences last time, so we're going to continue to cover that today, and then you're going to have a worksheet covering that as well. So the first step is we need to determine if it is actually arithmetic, so you need to find a pattern. So the first step is going to be finding the common difference. So that's the same number you add every time. Remember, this number can be a positive or a negative number, okay? I kind of did the order wrong. So first is finding the common difference. Second would be the explicit formula, which is going to be this one down here. And then the third is going to be finding the 52nd term. Okay, so I kind of started this one already. For the sake of time, I'm not going to do every single one again, but we do want to make sure that you are double checking. So just because the first two terms have the same number, you want to check every single time, because if it doesn't have the same pattern every time, then it automatically is not going to be a arithmetic sequence, okay? So remember, you're going to take a number on the right, then subtract the number on the left. And then you're going to do that with every pair. So for this one, the one on the right is negative 21. The one on the left is going to be negative 30. And then when you do same for this one, when you see the number on the right is negative 12, the number on the left is 21. And then it's going to continue this way as well, okay? So just looking on the calculator, if I have a negative 21, and then I subtracted a 30, make that negative, I'm going to get a 9. And you're going to see, if you do that on your calculator, every single time, if you add, you're going to add 9 to the number on the left, and then you get the number on the right. So that's going to be our common difference. Our common difference is 9, and we represent our common difference with D. So D is equal to 9, okay? Now, the next part is asking for the explicit formula. So essentially what we're going to do is to take that formula in the yellow. So the nth term is equal to the first term. So that's going to be our very, very, very first term we have right here. That very first term is going to be that A1. Then be negative 30. And then we're going to add, and it's going to be n minus 1 times D, and our D is going to be 9. Okay? We're going to go ahead and distribute this. A to the n is equal to negative 30 plus 9n minus 9. We can actually combine these two. Remember, we're going to add similar terms. So we'd add n's with n's and add the constants with the constants. Negative 30 is a constant, negative 9 is a constant. So a to the n. So we can see it's negative 30 minus 9. So I'm going to put in here 30, make it a negative, minus 9. That's going to give me negative 39. And this is going to be your explicit formula, okay? Now we can use our explicit formula to find the 52nd term. So a to the 52nd term is going to be negative 39 plus 9 times 52. Definitely don't know that on top of my head. So it would be 9 times 52 is going to give me 468. So a 52nd is equal to negative 39 plus 468. Okay, so we're going to throw that into our calculator. So it's going to be 39, make that a negative, plus 468. That's going to give me 429. Okay, and now we have all three parts. So we have our common difference, which is number 1, our explicit formula, which is number 2, and our 52nd term, which is number 3. Okay, so we're just keep in mind what it's asking, common difference, explicit formula, and which term, okay? Let's go ahead and go to number 2. So let's say we have these numbers. We have 31, 51, 71, 91. Ooh, I like those numbers. I like that pattern. Okay. So what I'm going to go ahead and do is take my calculator. We're going to take the number on the right, which is 51. And we're going to subtract from the number on the left, which is 31. And that's going to give me 51 minus 31 equals 20. Okay. And you can do that really for every single set. So 71 minus 51 equals 20. 91 minus 51 equals 20. So that's going to mean our common difference. Sorry, this is supposed to be 91 minus 71. Okay, that means our common difference, or our D, is going to equal to 20. Now we can go back to this formula right here. A of n equals A1, and our A1 is going to be our 31, times n minus 1 times our D, which is 20. Okay, we're going to distribute that across. And then we're going to get A of n equals 31, and that's going to be a plus in between, right? Yeah, plus. It's going to be 31 plus 20n minus 20. Same thing as before, we can combine our constants together. So A of n, big N. A of n is going to equal to 11 plus 20n. And I got that 11 by 31 minus 20, and that would be a calculator problem if you don't know it off the top of your head. Okay, and then our 52nd term, so a to the 52nd is, when our n is 52, it's going to be 11 plus 20 times 52. And I don't know what 20 times 52 is off the top of my head. That gives us 1,040. Okay. And that's going to be our 52nd term. Okay, let's look at another one. Negative 37, negative 44, negative 51, negative 58. So same thing as before, it would be negative 44 minus negative 37. And this would be the negative 51 minus negative 44. And that would be negative 58 minus negative 51. And then every single time, it's going to give you a negative 7. And just for the sake of time, I'm not going to put it on the calculator, but I would definitely suggest for you to double check everything in your calculator. Okay, so the explicit formula. So it's going to be the first term, negative 37, plus n minus 1, and our D is negative 7. Okay, and same thing, distribute that number. So it's going to be A of n equals negative 37 plus negative 7n plus 7, because that negative times a negative is a positive, so it gives us a positive. So we have negative 37 plus 7 in your calculator. That's going to go ahead and give us a negative 30. And then we have adding a negative 7n. So remember, when you're adding a negative number, that's the same as subtracting. So you can rewrite that as the nth term is going to be negative 30 negative 30 minus 7n. Okay. And then, so just remember for any of these, the first numbers are first term. So like something like this for number 1 could represent money, right? So let's say that we have $30 invested in a lemonade stand, and every day you make $9. After the second day, you're only negative $21. After the third day, you're only negative $12. And you want to know how much money you have after the 52nd day, you're going to have $429. So just kind of, if you get confused, think about this in sense of either money or, I know we talked about like the stadium, whether it's like the Staples Center or whatever. So let's say the first row has 31 seats. That would be n is equal to 1. That's the first row. N equals 2 would be the second row. That was 51 seats. So every single time more seats are added. Okay. When it's negative, I'd probably just say stick with money, because usually that's the best way to understand a negative number. So let's take a look at another problem. This one's going to be a little different than the other ones, but I want to make sure you at least have this example. Okay. So let's say we have 107. Then you have 1,073. Then you have 10,733. And then you have 107,333. Ooh, big numbers. Nope. Commas in the wrong spot. Sorry about that. Okay, great. So we're going to take these numbers, and it's going to be 1,073 minus 107. And so we added 966 to that number. Okay, now we're going to take our next number. So it's 10,733 minus 1,073. That gives me 9,660. They are not the same. You could continue going, but since you already know that these two are different numbers, you already going to know it's not arithmetic. Okay, so that would actually be your final answer.